Okay guys, so in this video let's talk about the magnetic properties of complexes. So there are two main categories. One is we call as paramagnetic, and the other thing we call as diamagnetic, right? Other thing we call as diamagnetic. So what is paramagnetic? Paramagnetic means the complex has magnetic properties, like it has magnetic properties. Like it attracts to magnets. But this is diamagnetic means the opposite. It doesn't have magnetic properties. It does not right. So how we can identify whether a complex is paramagnetic or diamagnetic? So in this case, let's see, if a complex is paramagnetic, then it must have unpaired electron. What are unpaired electrons? Like if I say like this, here we have 3 orbitals. I'm going to fill this up like this one. This has an unpaired electron. Here, this is the unpaired electron. These are paired electrons. This is an unpaired electron. So if my complex is paramagnetic, it must have at least one unpaired electron. So in this case, it does not have unpaired electron. If there is unpaired electron, then it is a paramagnetic property. So this is the basic concept of paramagnetic and diamagnetic. So let's move into an example. Okay, so let's take an example, right? So let's go for a hypothetical one. So there is a M2 plus complex, right? M2 plus complex, which the electron configuration of this M2 plus metal is given, right? So it has D6 electron configuration, which means M2 plus configuration, right? You do not have to reduce to. You have been given that this complex is octahedral, and delta O is less than the pairing energy. So this term we have talked this about the last few videos. If you have not familiar with these terms, like the splitting parameter, the pairing energy, I highly recommend you to go back to that video and watch it. It's a very small video, like 8 minutes or 10 minutes. I do not remember how long length it is, but it's small. That's not lengthy video, so you can easily go for that video and check it. So now this question, try it out, pause the video and try it out. You need to find the electron configuration, like each d orbital, and find whether this complex contain unpaired electrons or paired electrons. So let's move it. This is an octahedral geometry, right? So the structure should be like this, the d orbitals, right? I'm talking about d orbitals. So d orbital structure should be like this. This is Eg and this is T2G. Now we need to fill 6 electrons, right? We need to fill 6 electrons. The first 3 is completely fine, but when we are filling the 4th electrons, you need to consider this contradiction. Like, so as you can see, the splitting parameter or the energy gap over here is much less than the EP, right? It is much less. So pairing energy is larger, which means the pairing is much harder. So the 4th electron won't go for a pairing, it will go for the upper energy level. So 1 2 3 4 5, now there are no space, so it will go and pair for the next. So as you can see, there are paired electrons. There are unpaired electrons, which means the complex is paramagnetic. Complex is paramagnetic. So if this is given like other way around, if this is given other way around like this, then the situation change, right? As you can see, let me erase this. Now if I'm going to fill up the orbitals 1 2 3, the first 3 is completely fine. I need to fill another 3 electrons. As you can see, the delta O is now larger. This energy barrier is much larger than the pairing energy, so I can go for here and here and here. As you can see, there are no unpaired electrons, which means this is diamagnetic. This is the simple problem, right? I hope you get the idea. This is the idea you need to get. So this is the thing about magnetic characteristics. I hope you got the idea.